What's up, YouTube? Are you ready to drag and drop? Too smart? Well, that's what the episode today is gonna be about. Okay, I promise to calm down, but I'm excited because this is season 10 or module 10 of programming with Qt Widgets. This is episode 67, and just think about how much we have been through together by now. In this episode, we'll talk about drag and drop, which is one of the most intuitive things for a new user. If you have kids or grandkids, or heck, if you're a kid yourself, I'm sure at some point you'll have observed a minor walk up to the TV and try and drag and drop on the TV, because that's just in our DNA. There are 5 steps to a drag and drop operation. At least I'll talk about 5 things here now. The first thing is to identify that a drag and drop is about to happen. The user presses down the mouse button and moves the mouse a certain amount of pixels on your widget, indicating, hey, I would like this to be a drag operation. Then, when you've identified that a drag operation actually is about to happen, you need to tell the system that, hey, there's a drag operation going on now. Could you please change the cursor to show that? And the data for the drag, the data being dragged out, is this. Then there is the drop side. And on the drop side, you first need to identify that a drop is about to happen, or rather that a drag is being dragged onto your widget. And you'll tell the user, hey, I can accept this, or I can't. Imagine that you're implementing a simple text editor and a user tries to drag a video on you. You might not be able to accept a video, so you simply say, sorry, not for me. And finally, the user will release the mouse button and you will decode the data in whatever format makes sense. And in addition to all of this, there is the data part, namely how do you encode and decode data that isn't just out of the box plain text or image JPEG, but your own data. And we'll address that too. So step number 1, detect whether you should start a drag. And how that is done in your application is entirely up to you. But the usual way that it's done is that the user presses down the mouse button and moves it a certain amount of pixels. So what I have implemented for you here is just a template for what it could look like should start drag with a QMouse event. I imagine that being called from your mouse move event method. So in the mouse press event, you remember the current position that the user pressed down, and then when he moves it, you will tell whether he has moved it long enough for it to be considered a drag. So let's just dissect the method. First of all, we are testing whether the left mouse button is being pressed down. If that is not the case, well, then obviously it's not a drag operation. We can say, no, you shouldn't start a drag. If it is pressed down, we'll go and ask the system for how long do we usually want to move before we consider it a drag. And that's one of those settings. So if you, for example, have a user that has Parkinson, then they might not appreciate that you start a drag after 10 pixels or however much the default is. They might want more pixels. Or, well, maybe that's an additional feature for your application, one of those tubes that you can blow into. So if you have been drinking heavily the night before and you are shaking today, then you'll increase the length. That would be awesome, wouldn't it? Anyway, jokes aside, this is the distance that the user should be dragging the mouse before a drag should be considered. And then taking these 2 points, subtracting them, calculating Manhattan length and comparing to that distance, that is what will decide whether we should start a drag or not. And go and look at the style hints here on your QGUI application. There is a few other settings for when should a drag be started that you might want to consider in your application. So that was the warm-up, the detecting whether we should start. So this is what step number 2 now looks like, starting the drag. So we have a mouse event, and in our mouse event, we test whether we should start a drag based on the event itself. And if we want to start a drag, then what will happen is that we create an instance of a QDrag object. We create an instance of a QMimeData. That is where the data being dragged out are stored in. QMimeData, in this very simple setup at least, just has a method that's called setText, where we'll give it some text. So data to drag out is a QString that somehow I can calculate in my application. It's not a virtual method or anything, it's just something that I came up with. The MimeData now has the data we want to drag out. We set that on the drag, and we call exec on our drag to tell Qt, to tell your operating system that a drag and drop should now start. Exec will not return before the drag and drop operation has been completed. And when it has completed, what exec will return you back is what kind of drop happened. Was it a copy? Was it a move? Was it a link? And if it's a move, then obviously you need to delete the data on your site. What is in the ... part here is, well, telling what kind of drag operations you will accept out of your application. So if you cannot move your data out of, you cannot copy it out, then you can tell it, hey, you can only do a move out of this operation because there's no way for me to clone the data. It wouldn't make any sense. Or, hey, you can get the data, but I'll definitely keep it myself, so you can only copy it out. Or, well, you can copy, link, move the data. That's what you tell with the 3 dots. Observe that as soon as I come into the conclusion that, hey, I will be starting a drag and drop, I will not go back into this code here. So my exec will block me there. So I won't get any more mouse move events. However, the drag or the exec call will start a new event loop. So other events will be handled. So be careful with that. Finally, if it's not a drag, or if I shouldn't start a drag, then I'll call my superclass as usual with its event handler. It might need to do something itself. And then observe, as it says here, that the drag and the MimeData both need to be allocated using new. And I asked my good friend Giuseppe De Angelo about why is that, and his answer was along the lines, well, drag and drop on all the known platforms is a pile of, why would I repeat what he said? I'm just going to be beeped out anyway, because that was literally what he said. It's a big hack on all systems to do integration of drag and drop. And that's why some of it happens after the exec has happened. Not anything we need to worry about, but Qt needs to take ownership of the drag and the MimeData. So just be careful to not allocate them on the stack. I did try once, and I got a brutal notice from the operating system that was not a good idea, called a segmentation fault. So if you do, you will be notified. Don't worry. Obviously, we can drag more out than just the text or just a text. We can drag out images and URLs and whatnot. And I have a table here for you that shows you the kind of things that are built into QMimeType or QMimeData. We can drag out text, HTML, color, images, URLs, and then of course your own data, as we'll see at the end of this section here. And here are the different methods for how you write and read, and of course test whether a given MimeData has a given type. So if you have a MimeData and you would like to know, do you have HTML, then you can ask, has HTML on it, which we'll see on the drop side shortly. This is the MimeData that those things are encoded in, which is useful to know just in case. And of course, if you have something that is your own data, or you need to interoperate with something completely different, then data is how you will be communicating, and the MimeType is whatever MimeType that you are dragging out or accepting drops off. But we'll talk about that shortly. But first, how about an advertise? Going from Qt 5 to Qt 6 is fortunately not as bad as it was to go from Q3 to Q4, but there's still that little devil in the detail. And you will only do it once. For us, we do it every day. So talk to us, we can help. With that out of the way, we have now covered the drag side of things. And that's why I thought it would be a good idea to have the ad here, because now we're going to the other side, namely the drop side. And you do not need to implement both the drag side and the drop side in your application. It might be that you just want to drag out text that can be dropped into your email program or whatever you want to do. Or you might just want to accept drops from something else that the user can drop, say, an image on you, which is an attachment to your mail if you're implementing a mail client. So what does it take to accept the drop? Well, first of all, I need to implement drag enter event. And what drag enter event, well, it is called on me whenever the user enters with a drag operation my widget. And then it'll call on me and I'll go and ask the event for its MimeData. And that MimeData had a number of tests. Remember, the test up here has text, has HTML and so on. And I'll test whether it has the MIME type that I'm interested in. And obviously, I could be interested in multiple ones. I could test whether it has HTML and then put it into my QText edit as HTML. Or if it didn't but has text, then I could put it in as regular text. In any case, what I need to tell, and that's important, I need to tell it that I accepted it if, of course, I did. Because that will change the cursor on my system to be something that indicates that, hey, you can drop here. And then based on Control and Shift and whatever on the keyboard, it will tell, and of course, what operations you on the drag side, or what the drag side accepted, it will show a cursor indicating whether it's going to be a copy, a move, or a link. That's step number one. And step number two is to implement the drop event. And in the drop event, again, you go and ask for the MimeData. And this time you go and ask for the actual data. And again, this is the test. And this is for reading that data out of your MimeData. And now you will do whatever you need to do with that data that was dropped on you. And you'll have to tell Qt, which will tell your operating system, that you accepted the proposed action. If there was multiple drag actions happening, so the drag side says, yeah, you can copy, link, or move whatever you want. My default preference would be copy. And you said, well, yeah, I know that you would like to copy on me, but I cannot accept a copy. You need to move it on me for it to make sense for me. Then instead of saying accept proposed action, you will set, you call set drop action, I believe it's called. And I actually prepared over here. See, set accept proposed action. This is the implementation. It simply says the drop action to be this and call accept. And we have the set drop action here. And the set drop action, I can see the implementation of that if I want to. Set drop action is just telling what actions I actually was accepting as the drop. And just as up here, I need to call accept. So my accept proposed action is both setting the action being dropped and it's calling accept. But if you do want to use another one, you will have to say set drop action and call accept. And it's super important that you call accept, otherwise the drag side will think that drag and drop was canceled. And especially if it was a move, it will think, hey, it was canceled, but I'll just keep my data because, well, it was canceled. So that's the two things for the drop side. You need to tell it, hey, or you need to tell whether you can accept the drag, and you have to accept the drop. And then in comment up here, it says you can also implement drag enter event and drag leave event. And drag enter event, that's what we had, drag move event and drag leave event. So imagine that you had some user interface where you had a large widget that could accept drag some places on it and others it couldn't, then you can call drag insert event and say, yeah, I cannot accept drag right here, but and then implement drag move event, and implementing drag move event, you can later on say, yeah, here I do accept it. And then drag leave event is just in case you somehow highlighted your widget to indicate that, hey, sure, this part of the widget actually do accept it. Then in drag leave event, you can unhighlight or simply repaint your widget. Okay, if all you ever want is to drag out images and text and URLs and accept drops of those types, then fine, you can stop watching now. But in case that you have some other data types, an existing MIME type, for example, I don't know, a video format or something that you want to be able to drag out, then you need to follow on. What I'll show you here is not how to encode a specific video format. You'll have to look up for what is the actual order of bits in that video format. But I'll show you a simple example of where you're just dragging and dropping between your own existing applications. And in that case, we have a very useful little helper class called QDataStream that will help us take our bytes and put them into, well, a QByte array. Because the media that the drag and drop system is using is an array of bytes. That's those things that have 8 bits in them, and your whatever you have needs to be encoded into that format. So what you see here, again, is my mouse move event. And in my mouse move event, I've decided that I should start a drag. And just as before, I'll create an instance of a QDrag. And that QDrag needs an instance of a QMimeData. But to get my MIMEData, what I need to first do is create a QByte array. And if I create a QData stream on that byte array, I can simply stream my data in. So in this example here, which I'll show you a running example of in just a few minutes, I have 2 colors and a orientation, either horizontal or vertically, that I want to stream to the other side or to put into my drag operation. So create my data stream on my byte array, do the stream, and now it will show up as bytes in my byte array. And I'll have to create my QMimeData as before. And this time, my MIMEData, rather than calling set text or set whatever the other few was, I now call set data, which needs 2 things, the byte array and a MIME type. And the MIME type is a classification. And there is I don't know if it's a standard or just a common sense that those that are not standardized, they start with X minors. That's why it's called X gizmo dash X drag. That's because that's simply the major type and the minor type. So text plain or text HTML and image JPEG and image PNG and so on is what you usually find in here. So the bytes are now in the drag, and the drop side, of course, will have to decode the data in exactly the same format. So in our previous example, we saw 2 colors and an orientation, so we need to take out 2 colors and an orientation. And the first thing, of course, for the drag side is to test whether we can accept that kind of drag. So this time we are using hash format on the MIMEData to test again against the string that I had. And if I wanted to accept just a standard image JPEG, then I could say hash format image JPEG and then take and decode it, of course. But here I'm imagining that I'm dragging my own kind of data. And then in the drop side, as before, I'll go and ask for the MIMEData from the drag and drop. I will test if that MIMEData can do gizmo drag, then I will take out gizmo drag. And now I have a byte array. Using my data stream, I'll stream the opposite. So now I'm streaming into the data of my object. And as before, accept proposed action or set drop action and accept. And of course, this one I always forget myself and like, why isn't it working? Oh, I did not update my user interface, which you do by calling update. Notice that on line 19.5 up until 19.75, whatever, I could have other tests. So after this one, if you do not accept Xgizmo Extrap, how about text plain, or how about image JPEG, or how about you could test a bunch of these different things. And the order that you test them in, of course, is the order of that is your preference. If you do not have any specific preference, you could instead go and ask the MimeData for the formats that it offers, and based on that, you could then go by the order that the drag site proposed. But that's up to you. One final word of warning that has bit me in the past is that let's go back here. I encode it like this, then I decide one day, I also need the color 3, so it would be good to have color 3 right here. And then I go over in my drop site and I decode 2 colors and orientation because my drop site had not yet been updated to color 3, and now my application crashes because I try to decode a color into an orientation, and that likely did not go well. So maybe the very first thing you should do here in your streaming is to stream out a version number telling, hey, this is version 1, and then over here test that version. Oh, if you were version 3 or later, then you need to stream out color 3. Okay, the last 2 things I'm going to tell you about drag and drop are really optimizations. So imagine that you were supporting dragging out videos, and those videos were 10 hours long. Then you didn't want to support it both in MPEG and MP4 and MOV and whatever video format there exists. I don't know anything about videos, sorry. What you want is to only put it out in that format when the drop site asks for it. So imagine that you had a video, you dragged it onto a text editor. The text editor could not render a video in there, but it could render an image of the video. And what you could then offer is, hey, I can give you it as a video / MPEG-4, or I can give it as image JPEG. And if you want image JPEG, then, well, you're not going to get the full video, but you're going to get 1 frame from it that might be representative for whatever you need. So in that situation, you do not want to encode the data until the drop has happened. And in that situation, what you can do is that you can subclass QMimeData and then implement formats and retrieve data. I don't know if formats is worthwhile subclassing, or do you just continue calling set formats, but wait a minute. No, you don't, because that was part of the constructor you specified the format. So you need to subclass formats. I just had a brain fart there. Sorry about that. And retrieve data is, of course, the important part. That is where your data is being encoded. Okay, let me admit, I've never done that myself. I've never had the need for such big data, which was why I was just for a second looking there. Why does it return a Q variant rather than a Q byte array? There is some documentation for it. Go and look at that. Otherwise, go to codebrowser.dev and look into the source code of the retrieve data method by default to see what or how it is being called. The second optimization is if you drag and drop inside your application, then you do not need to go through the full process of encoding your data. What you might do instead is simply to subclass from QMimeData and then override as we saw before, and you can, on the drop site, test whether the drop was actually happening inside your application. Because what you can do on the drop site is to ask it for its the source of the drag, and then if the source is the same, or if the source is not null pointer, that means that it's inside of your application. Again, a very detailed optimization that I admit I've never done myself, but now you at least know that it's possible. And with that in mind, let me just change and topic completely and talk about the clipboard. And you go, why are you talking about the clipboard, Jesper? Well, because the clipboard is also about moving information from one side to the other. It's a different way. With a clipboard, you control C and control V rather than moving the mouse to drag it along. But the core part of it is that you also have data to transfer. And if you look at it here, copy image is just my class that has a method called copy image. That is what is bound to Control C. I assume because I go to the clipboard or to GUI application, ask for the instance and ask for the clipboard. That's the only way I can get my hands on a clipboard. And I call set image. Okay, so that was Control C in my application here. I take the image that I have there and I put it on my clipboard. And to get it out from the clipboard, I go again to the clipboard here and I go to the QGUI application, ask for the clipboard. I go to clipboard and ask for the image, and now I put it back in. And you can see that my clipboard has set image and set pixmap, and it has set text, set image, and set pixmaps as the three operations on it. Not very much, but what it also has is set MimeData, and that is how you get data onto your clipboard. And then just go back a few slides to learn all about how you encode your data via drag and drop, because it's exactly the same operation. I wouldn't want you to leave this episode with only a bunch of snippets of code. I want you to have something that you can play with yourself. So that's what we have here. I have this application with 3 blocks on top of each other, and each of these blocks is a gizmo, and a gizmo consists of 2 colors and an orientation. And these 3 gizmos are put into a layout manager. And if you don't know about layout managers, then you should definitely rewind this series quite drastically. Let's see what a gizmo looks like. It's subclass in QFrame, which you don't see all that often, but you can see there is an outline around here to indicate which object has the keyboard focus, and that's actually coming from QFrame. It has a number of methods that we'll go into in detail. So first of all, my gizmo constructor here just remembers my 3 colors. Why is it not doing up in an initializer list? Well, I don't know. It set the focus policy to be strong focus. That is how it will actually be able to have focus outline. And I say set accept drops. If I do not set that, then drops will simply not be accepted. Then my paint event, again, we've talked about painting a lot, so there's no reason to talk about that, but that's the painting of this here. My size hint, if I hadn't specified a size hint, it would have been 0 by 0, which would have been rather dull. Okay, let's start with the drag and drop operation. So it should start drag. That looks like this, and you have definitely seen that before, because that's exactly the code that we had on the slide, testing whether it's a left mouse button, and if so, whether the Manhattan length is longer than start drag distance. It doesn't come from style hint here. I think the style hint was added later than this example, but I'm sure that this method just calls onto the style hint. Then we have the mouse press event. Here I remember the position of the mouse move event. If I should start a drag, then do start it. Set the data to be MimeData here, because I'm encoding my own data. And call exec with a copy operation, because I can't move them out of, if I had moved, then I would need to tell the layout to move them out. And then call mouse move event on the parent in case that it wasn't a drag that was about to start. On the drop side, drag enter event, can I handle text, or is it the format xgizmo xdrag? Doesn't matter which order these twos are in, because it's just a boolean that I'm saying yes to, either off. And then if that's the case, then I will accept the drag. And then finally the drop side, I will decode whatever came in here. And if I'm successful in decoding, then I will say that I accepted the proposed action and I will update. And as you can see, I can drag my gizmos around. I even have one over here. That's complete different application. I started from my shell, so I'm dragging between applications here, and that also works just fine. Then there was the toHelper method that we had there, the MimeData. MimeData looks like this. I create an instance of a Qt byte array. I take my stream, put it on the byte array. I stream my 3 colors and the orientation. I stream that as an integer. It is, of course, an enum, but stream it as an integer. I create an instance of MimeData. I set the data here of the type xgizmo xdrag to be that data that I just streamed into my byte array up here. And I also set the text to be mcolor1.name, mcolor2.name, and orientation either vertical or horizontal. So just in case that I have a shell here and I drag, I can also drag onto the shell, and you can see the shell obviously do not know about my gizmo drags, but it does know about plain text, which it then accepts here. And then I return that MimeData. So I did encode 2 pieces, or encoded the information in 2 different formats so that the receiving side could choose whichever format it was. On the decoding side, that was in my decode MimeData here in my drop event. What it does is that it tests first, do you have it as gizmo drag? If that is the case, then the data, give me that data as gizmo drag here. I create a data stream. I stream the other way this time, and I set the orientation to be that temp that I have there. And I say, yes, that's perfect. I have now streamed the data into the object again. If you, on the other hand, have it as text, then I will handle that too. And you could very well argue, why on earth are you having your own protocol if you can just stream it through text? And you are entirely right. This is purely to show you that I could do different data types. Imagine that this one up here had more power. It could, for example, also, I don't know, some additional information could be encoded with this version here, while this would be the cheap version that could, for example, only tell, hey, I'm tracking out from the Gizmo application. And that was drag and drop. And I'll show you how cheap it was to also add clipboard. And that was why that slide showed up there too, because my clipboard now, if I can find that up here, my mouse, my key press event, where are you? Key press event. If the key is the C key and I have control press down, that means control C, then I'll go and ask for the clipboard. I will set the MimeData to MimeData. And that was the method that encoded the current object into a QMimeData. If it's Control V, then I'll ask the clipboard for the MimeData. I will decode that, and that was the method that would take a QMimeData and put it into the object. And voila, I both have drag and drop and cut and paste in my application. There is one set of classes that are extra interesting when it comes to drag and drop, namely the model view classes. That's QListView, QTableView, and QTreeView. And these classes have drag and drop built into them. And the burden then is on the model only to provide the data. So that's the encode and decode data that you saw in the previous example here. I'll talk about that in the next video. So until then, have a great time.